welcome to True Projects. In this video, we are going to explain about the project that is cutting edge intrusion detection in IoT networks, a focus on ensemble models. So before getting into the execution, first let us understand what is this project about. Internet of Things, that is IoT. They connect billions of devices from smart home gadgets and healthcare monitoring to industrial sensors, allowing them to share data and work together seamlessly. So, this connectivity brings great convenience and efficiency across many areas of life and the industry. However, it also introduces serious security challenges, as many IoT devices have limited processing power and basic security protections makes them vulnerable to attacks. So, hackers can exploit these vulnerabilities in various ways, such as injecting malware, launching denial of service attacks, impersonating devices through spoofing, carrying out phishing attacks, or even physically tampering with devices. Such attacks can compromise sensitive information, disrupt services, and also reduce the reliability of entire system. With the global rise in IoT related cyber attacks, it has become critical to component that is to implement strong security measures to protect both the individual devices and also broader infrastructures that rely on them. So traditional intrusion detection systems or IDS are becoming less effective for IoT networks. These systems usually rely on fixed patterns of known attacks, which means they often miss new or evolving threats. They can also generate many false alarms, making it harder for network administrators to respond efficiently. So, IoT networks are highly diverse and constantly changing with devices that vary in capability and behavior. This complexity requires security systems that are lightweight, flexible, and accurate, and that are able to quickly recognize unusual activity or new types of attacks. Without such advanced detection methods, IoT networks remain exposed, leaving both organizations and users at significant risk of financial losses, service disruptions, and operational problems. So to overcome from all such issues, the proposed system it designs a smart intrusion detection based system. So it designs a smart intrusion detection system that uses machine learning specifically for IoT networks. It is trained and tested on the dataset that is RT-IoT 2022 dataset, which includes examples of both the normal attack, that is normal network activity, and various types of attacks, making it realistic for evaluating the real world scenarios. And here, the main goal of this project is to accurately classify network traffic and detect any malicious activity. By using advanced machine learning techniques, it aims to identify threat with high precision, meaning few false alarms and strong accuracy and recall, ensuring the most attacks are caught reliably. And here, to build the effective intrusion detection system, here we are using several models that are random forest, k nearest neighbor, support vector machine, decision trees, gradient boosting, XGBoost, and extremely randomized trees. Special focus is on ensemble methods, which combine multiple models to take advantage of their strengths, resulting in better performance when dealing with diverse and constantly changing nature of IoT attacks. And to evaluate how well these models detect intrusions, the project uses key performance measures that are accuracy, precision, recall, and FN score. These metrics helps to determine how reliable the system is in correctly identifying attacks, minimizing false alarms, and ensuring the most malicious activities that are detected effectively. So the proposed system it provides a strong adaptable solution for detecting intrusions in IoT networks, and it is designed to handle evolving cyber threats, effectively reducing the number of false alarms while keeping the network secure. This ensures that IoT devices and operations remain reliable, safe, and protected against potential attacks. And to further improve the performance of this project, here we are incorporating several things. So first it uses XGBoost model. XGBoost index selection and Smotin resampling technique to deal with the imbalanced data. So first it incorporates XGBoost index selection and Smotin resampling to deal with the imbalanced data, ensuring that rare attacks are properly recognized. And we are incorporating voting classifier. So this voting classifier, it combines random forest, extra trees, and light GBM, and it is used to further improve the prediction accuracy across different sets of selected features, making the system smarter and more robust. And here, the project also incorporates explainable AI techniques, specifically LIME and SHAP, to make the model's decisions easier to understand. These methods show which features are most important for making the predictions, helping users and analysts see why the system identifies certain traffic as normal or malicious. This improves the transparency and supports more informed and confident decision making. And furthermore, we have developed a simple web interface by using Flask framework. And complete with the user authentication for security. This allows users to safely enter the data and get predictions from the trained model in an interactive way, making the system practicable and accessible. Moving on to implementation, to implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented the project. First, we have loaded all the necessary Python libraries that are required for data processing, machine learning, and visualization. Then comes data ingestion. So here we will be loading the data set into Pandas data frame to prepare it for analysis. Then comes pre-processing stage where we handle missing values by either dropping them or filling them using appropriate methods. We convert categorical variables into numerical format using label encoding, and we standardize numeric features to ensure consistency across the data set. And we have used smoothing technique to balance the data set, ensuring that rare attack types are adequately represented. Then comes data visualization. So at this stage, we explore and visualize the data to understand pattern, distributions, and relationship between features. Then comes data splitting. So here we will be splitting the data set into training and testing sets. So training set is used to train the model and testing set is used to evaluate the model. Then comes model building and training. So here we will be training various machine learning models on the prepared data to detect intrusions. And then comes assessing the model. So here at this stage, we will be evaluating all the models that we have developed using accuracy, precision, recall, and FN score. And we analyze confusion matrix to understand the number of false positives and false negatives. And generate precision recall curve graph to evaluate how well the models identify the attacks. After that, we have applied explainable AI techniques that are LIME and SHAP to interpret which features are most important for the predictions. And the best performing model is saved for the future use. Coming to the part of front end. So here we have developed a front end using Flask framework, which provides a user-friendly interface for entering the feature values. And we will be loading the saved model to do the prediction. So we will be pre-processing the input given by the user that will be pre-processed and predict whether the input represents normal or malicious traffic and return the results to the user. So this is how we have implemented. Now moving on to the algorithms used. These are the algorithms used in this project. So k-nearest neighbor we have used support vector machine, decision tree, gradient boosting, XGBoost, random forest, extremely randomized trees, and we have also used voting classifier, which is an extension model. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So these are the source code files of the project. Let's understand each of them and how will they be used in this project. So in this folder, we have the data set that is used. So this is the data set that we have used in this project to train the models for predicting the attacks. It's opening, just wait for a while. Until then, let's see with the other files. So let's get back. And this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases. So in which we have sample files that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook file, which is a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. This is all about the code folder, and the dataset is also open. So here is the dataset, and here we have many features based on which we will be training the model for predicting whether it is attack or normal. So here we will be selecting the most important features from these different attributes. And here we have attack type. So close this. Let's execute it. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open Anaconda prompt. So it is open. Give the command cd. So give the command cd and give the space. Paste the copied path. Click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So this is the localhost, and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Chrome, so I will paste it in that. So paste the link here. Now click on enter. And this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of this project. And you can click on explore more, or you can click on register. So let's click on register and enter all the details to create an account. I have already created, so I'll directly sign in, click on sign in and give my username and the password to log in. Click on sign in. We have signed in successfully and redirected to prediction page of the project. So here you can see various parameters, right? So these are to be given as the input to predict the attack type. So first one we have is the backward packets payload standard. This measures how much the size of packets sent back, that is responses varies from the average. Then we have backward packets payload average. It is the average size of all response packets in the connection. Then we have forward URG flag count. It is the number of packets in the forward direction that have URG flag set indicating the urgent data. Then we have ID response port. It is the port number used by responding device in the network communication. Then we have forward PSH flag count. It is the number of packets in the forward direction with the PSH flag indicating immediate delivery of the data. Then we have active min. It is the minimum time duration that a flow was active during the session. And then we have forward packets payload min. It is the smallest size of the packet sent in the forward direction. We have service type here. It is a type of network, that is service or protocol being used. It may be HTTP, FTP or DNS. Then we have active average. It is the average duration that the flow was active during the session. Then we have forward header size total. So it is the total size of all packets headers sent in the forward direction. Here we have protocol. It is the type of network protocol used. It may be TCP, UDP. And here we have backward subflow bytes. It is the total bytes sent in the backward direction for the subflows. And here we have forward last window size. It is the window size, that is the amount of data allowed to be sent before acknowledgement. It is of last packet in the forward direction. And here we have flow IIT min. It is a minimum inter-arrival time between consecutive packets in the flow. And here we have forward header size min. It is the minimum size of packet headers in the forward direction. Then we have flow win flag count. So here we have flow win flag count. It is the number of packets in the flow with the win flag indicating end of communication. Then we have flow packets payload average. It is the average size of all the packets, that is forward plus backward in the flow. And here we have backward int, that is init window size. It is the initial window size of the first packet sent in the backward direction. And here we have forward packets payload average. It is the average size of packets sent in the forward direction. And here last we have forward IAT min. So this is the minimum inter-arrival time between consecutive packets sent in the forward direction. So this is all about the parameters. Now let's enter them. For that, open test cases. So open test cases, open sample. So here we have files, I mean sample test cases. So let's apply filter to the attack type that we will be predicting now. So we will be not giving input this column. So this column will not be given as input because this is only that we will be predicting. Let's apply filter to class 0. Click on apply, I mean OK. And let's start entering them. Let's check with this case and let's start entering. Where here we have backward packets standard deviation, that is backward packets payload standard deviation is 0. Payload average is 0. Urge flag count is 0. And then ID response it is 5353 0 0 47 and service type is DNS service. Select the DNS service. Active average is 0 and then forward header is 8 and then protocol is UDP. It is the UDP protocol and backwards upflow bytes are 0 0 0 and forward header size is 8. And here we have flow min flag count. It is 0 47 0 0 47 and the last value we have is the 0. Now click on run ensemble prediction. So this given input, it will be pre-processed at the backend. It will be feed it to the train model and the train model will be giving us a prediction. So here you can see ARP poisoning threat has been predicted with a 97% confidence score. And here we have critical threat. So it is a critical threat. First, it is classifying which type of attack it is. And then it is predicting whether it is critical, low, high, like that. And then here we have attack description. It is about ARP poisoning attack. And here we have potential causes why this attack has been happened. Here you can see potential causes. And here we have safety measures for that. Here we have related information. Let's try with the another sample. So let's apply filter to class 1. Click on OK. And let's check with this case. So backward packets payload are 0, 0, 0 and 80. Forward PSH flag count is 4. Active min is 1.08. And forward packets are 0. Service type is HTTP. So select the service type. And the average is 11197. So paste it. And forward header is 200. TCP is the protocol. Select TCP and give the backwards upflow bytes. So here we have 0, 502. Copy the flow IIT min. And then we have the other values, that is forward header, that is 32. Flow fin flag count 0. 19 is flow packets. 6510. Backward init window size 35. And then 9.65. Now click on run ensemble prediction. And here we got the prediction as DDoS slow loris has been detected with the 99.64 and it is also a critical threat. And here we have attack description, potential causes, safety measures and related information for that particular attack. Let's check with the other class. So let's apply filter to class 2. Click on OK. And let's check with this case. So first the values are 0. Similarly, I will be entering all the values. So here I have entered all the values. Now let's click on run ensemble prediction. And Here we got the prediction that it is DOS SYN hipping attack and with the confidence of 100%, which is also a critical threat. And here we have attack description that SYN flood attack using hipping tool to overwhelm the target server with SYN requests, causing it to become unresponsive to legitimate traffic. And here we have potential causes, safety measures, related information. Now let's check with the other class. So let's apply filter to class 3, apply filter to it, click on OK. And let's check with this case. So I will be entering all the values where backward packets payload is 8.86. Accordingly, I will enter all the values. So I have entered all the values here. Now let's click on run ensemble prediction model. And here we got the prediction as it is meta exploit brute force SSH attack. So here you can see Metasploit brute force SSH attack for the 100% confidence score. And here we have critical threat. Now here we have attack description and here we have potential causes for this attack. Here we have safety measures also and related information for that attack. Let's check with the other case. So click on that and let's apply filter to class 4 and start entering the values. And here we have backward package that is 300 0.4. Similarly, I will be entering all the values. So here I have entered all the values. Now let's click on run ensemble prediction. And here if you see we have MQTT published attack has been predicted with a 99.96% confidence score and it is a critical threat. And here we have attack description about this MQTT published attack. And here we have potential causes, safety measures, related information about that attack. Now let's check with the other class. So let's apply filter to class 5 and click on OK. So let's enter all these values where backward packets are 0. So similarly, I will enter all of the values. So here I have entered all the values for the class 5 and let's run ensemble prediction model. And here if you see we have ARP poisoning attack, which is of 56.11% confidence score and here we have of low threat. And here you can see attack description, potential causes, safety measures and related information for this ARP poisoning attack and which is of low threat. Now let's check with the other class. So click on run another analysis and let's apply filter to class 6. Click on OK. And let's check with this case. So I will be entering all the values. So here I have entered all the values. Now let's click on run ensemble. And here we have the prediction as it is NMAP OS detection attack. So here it is NMAP OS detection attack, which is a critical threat with the 99.73 probability score. And here we have attack description, potential causes, safety measures, and related information for that attack. Now click on run another analysis and let's check with class 7. Click on OK. And let's start entering these values. So let's start entering them. So here I have entered all the values. Now let's click on run ensemble. And here we got the prediction that it is an MAP TCP scan attack with the 100% confidence score that is of critical threat. And here we have attack description. Here we have potential causes, safety measures, related information. Let's try with some more cases. So here we have class 8. So apply filter to class 8 and click on OK. And let's start entering them where let's start entering them. So here I have entered all the values. You can see I have entered all the values. Now let's click on run ensemble prediction. And here we got the prediction as NMAP UDP scan attack has been predicted with the 99.79% score with the critical threat. So here you can see we have critical threat and here we have attack description and here we have potential causes, safety measures and related information of the class 8. Now let's try with the 9th class. So apply filter to it. And let's fill in all the values. So let's check with this case. I'll be entering all the values. So here I have entered all the values. Now let's click on Run Ensemble Model. And here we have the prediction that it is NMAP XMAS tree attack. That is XMAS tree scan. Here we have the confidence score. Here we have critical threat for that. And attack description, potential causes, safety measures of that attack, and related information. Let's check with last two more cases. That is class 10. It's applicable to class 10. And let's enter the values. So let's check with this case. I filled in all these parameters. Now let's click on Run Ensemble Prediction. And here we have the prediction that it is MQTT publish attack with the low threat. And here we have 53% confidence score. And here we have attack description. Here are the potential causes, safety measures, related information. Let's check with the last case, that is class 11. Apply filter to it. And let's try with this case. So here I have entered all the details. Now let's click on Run Ensemble Prediction. And here we got the prediction as Wipro bulb attack, which is 99.76 confidence score. And here we have critical threat. Here we have attack description about Wipro smart bulb. And here we have potential causes, safety measures, related information. So this is how you need to do the prediction. Now let's check with the graphs. So click on View Analytics. And here we have multiple graphs. So here we have sample outcome graph, where on x-axis we have all the attacks that we are predicting. And on y-axis we have the count of each attack that we are predicting. And let's close this. Here we have top 20 features. On x-axis we have feature importance score, and on y-axis we have feature. So this feature has the most important score. Accordingly, all the 20 features are arranged according to that. Close it. And here we have class distribution. So here, before applying smoothing technique, here if you see all the cases except the DDoS, SY and hipping, all the other cases are very less count. So we have applied smoothing technique to balance this data set. And here you can see the balanced data set. You can see all the count are almost equal. Now close it. And here we have confusion matrix. So this is the confusion matrix. And here we have accuracy comparison graph. So here on x-axis we have all the models that we have used, and on y-axis we have accuracy. Now close this. Here we have precision score. Here we have recall score. And here we have FN score. Here we have XAI SHAP. So this is the XAI SHAP score, which shows the feature importance. Now click on logout. So in this project, we have developed a smart system that can detect and prevent harmful attacks quickly and accurately. So by focusing on the most important data and using advanced techniques, the system helps to keep online services safe, reliable, and running smoothly everywhere. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.